Hi children, this is Krishna Shastri, IIT Maths teacher, Velamar Vidyalaya Pathipattu. In the earlier classes, we have discussed our first chapter, knowing our numbers. In that the natural numbers we have completed, and also whole numbers, properties of whole numbers. So from our IIT concept, we have completed the fractions. Now the next chapter, we are moving to the next chapter, that is the very important thing, very important chapter, geometry. Geometry in our CBSE chapter, it is basic geometrical ideas. So in the basic geometrical ideas, first we should discuss what is geometry, what is the use of the geometry, why we need to learn the geometry first. Okay, geometry is first. In the ancient days, that means earlier days, there is no limit for the land for any person. There is no limit. The number of population is very less, so there is no need with the measurement of the land. So after some years, what happened is, when population is going to increase, the human got the occurrence as measuring the land. That means limits of the land is occurred. When limits we are saying there at the place, the measurement is needed. Whenever we are saying the limit is nothing but measuring. So that measurement is needed. That measurement happened in the ancient days. So to that particular person, this is the land we need to occupy. These are the measurements of the land, like that came. So for that we have that geometry is introduced. That means geometry is nothing but measuring the land. So geometry, the word which is taken from the actually from the Greek language. The Greek language word is geometron. Geometron. It is the Greek language word, not the English word. It is the Greek language word. In the Greek language word, it is geometron is the common word, single word, but it is the combination of two words. Those are the two words. Is one is geo and another one is metron. So geo and metron. So these two words are different to meaning. So that is geo is nothing but the meaning of earth. Already we know, we are reading that geography in our social. We will read the geography. Geo is nothing but earth, and metron is nothing but the measuring. Metron is nothing but measuring. So finally the geometry or geometron meaning is nothing but measuring the earth. So for measuring the earth, first geometry is introduced. After that, the geometry is introduced for the constructions, the building construction. For every construction we should measure the building, how much height we need to take, how much length, how much breadth we need to take. Those all are day by day it is implemented as occurred in the geometry. So for every measurement, like measuring the area, measuring the volume, measuring the length, whatever it is, we should know the geometry. So measuring is nothing but the geometry. So directly we can't go for the measuring. First we need to discuss the basic points, basic definitions. We need to know what are those basic definitions. First one is the very important one, point. This is the very important thing we need to know. Point. Point is nothing but if you take a sharpened pencil and you place one dot on your white paper, then you are able to see one dark dot, one black dot. Your pencil tip, how much is the very thin, that much very thin dot you are able to identify a mark on your dot on your paper. That dot is nothing but the point. The dot is nothing but the point. So what is the point? Here we are saying that point is represented. This is the point. So this point can be named as by using the capital alphabets. Capital alphabet, set of capital alphabets, we can use the representation of the points. So see, for example, we are writing this is point A. So it is read as point A. If we are writing right C, then it will be read as point C. This is point. So point is represented, or point is used for representing a location. See, now in these days we know we are very familiar with the Google Maps. So in the Google Maps, for example, I want to search Velamar Vidyalaya Pathipattu. Where is the location of Velamal Vidyalaya Partipattu? See, if you search that in your Google Map, then you are able to find out one water drop like this in your Google Maps. So that water drop is nothing but this fully is not the Velamal Vidyalaya Partipattu, but what is the tip of the water drop you are seeing, that tip indicates the Velamal Vidyalaya Partipattu, or else whatever the location we want that position. So this tip we will take as a point. This tip we will take as a point. That point represents the Velamal Vidyalaya Partipattu location. So by that we can say point is used for the representation of the location of any location. So we know the name, how to naming the point we learned, or what is the point also we learned. Now what are the dimensions of the point we should know. Dimensions. What are the dimensions? For example, I am taking point x. So we will read this as point x. Point x. We will read this as point x. Representation of point is in this way, but reading is point x. We should remember this. Representation of a point is this, and reading is point x. So now dimensions we should know. So for point, any point if you take, but you are able to see the point, actually the point is nothing but the dimensions of the point are not there. That means point doesn't have any thickness or breadth or length, but we are able to see. Whenever we are able to see, that must be have, that there must be one location, there must be one dimension. But actually the point exact definition is point doesn't have any breadth, length or thickness, but for representation purpose only we will use this small dot. Okay, so dimensions are almost nil. There no dimension for the point. Okay, these are the dimensions of the point regarding point. Next is we need to know what is line segment. Next we have as a line segment. What is line segment? See, for example, now what I am doing is, so already we learnt point is nothing but location. See, I am taking the points, 2 points here, 1 point, 1 location I am taking as city A and city B. Take these two are cities. Now I want to travel from this city to this city. Okay, I gave the 4 persons to travel. So one person is traveling in this way, and another person is traveled in this way, and another person traveled in this way, and another person traveled in this way. Okay, this is the first person traveled, the second person, and it is the third person, here the fourth person. Now my question is, who traveled the very least journey? Who did the least journey, or who traveled the least distance? Then we can say, by seeing this we can say person 3 traveled the very least distance. Why? The person from A to B directly traveled, so this is the very shortest distance between city A to city B. So the shortest distance who traveled, that person is the third person traveled the least distance. So in between two locations or 2 points, if we observe what is the least distance, that is called as a line segment. So 2 points, any 2 points, for example I am taking as x, y. These 2 points if we join directly in the straight away, if I join the straight away 2 points, then this straight line between the 2 points is called as a line segment. So smallest distance or shortest distance between the 2 points is called as the line segment. So definition 1 for the line segment is shortest distance between the 2 points is called as the line segment. So if we take the second definition, see, I am taking these 2 points as end points, and in between these two there will be the infinite number of points. We can observe there will be the infinite number of points. So these all infinite number of points if we join straight away in between the 2 end points, A, B I am identifying as the end points, and in between these 2 end points there are infinite number of points. Those all I joined. So now this is called as the line segment. So the definition, second definition for the line segment we can take as, if in between 2 end points, if we join infinite number of points, then we will get the line segment. See, here the end points are very important. End points are important. In between these two end points, if we join the infinite number of end points, then infinite number of points, then we will get the line segment. See, for example, I am saying this is the 10 centimeter line segment. Now, one person is asking that this is the 10 centimeter, okay, on the 10 centimeter line segment there will be the infinite number of points. Why? Point doesn't have any length or thickness or breadth. So we can say here 10 centimeter, in this infinite number of points will be there. Now one person is asking, I am taking one line segment with 0.00001 millimeter. So whatever the length we are able to find out, then that is called as that is nothing but the line segment. See, this is very small line segment I have taken now. What are the there? The question is, in this line segments also there will be the infinite points or not. See here we are 10 centimeter. Comparatively 10 centimeter is very bigger than that 0.0001 millimeter. So here we are saying that there will be infinite points. Then what about this small line segment? There will be the infinite points or not? Yes, whatever the line segment you are taking, either it may be 0.1 millimeter or 0.0001 millimeter, whatever the line segment you are taking, there will be infinite number of points will be there on the line segment. But here in all those infinite points, only two will be the end points. End point is nothing but there will be the, in the left side edge, if we observe, this edge end point is A and this edge end point is B. So in between the two end points there will be the line segment. Line segment will have the two end points. Now coming to the third definition. I am taking one line. Already in the earlier classes we have discussed that what is line. Line is nothing but, in the number line we have already seen, line is infinite length. It will have the infinite length and it will be direction also will be there. So it is, I am taking infinite length. On this line now I am taking, this is the line segment. See, you can identify that this is the colored part, you can take as the line segment. So we can identify that the length which is taken from the measured length which is taken from the line. So as earlier classes we have discussed that what is the fraction. Fraction is what? Fraction is the part of whole. Fraction is a part of whole. So the same way, if you take one part from the line, then it will be a line segment. A part of line is called as a line segment, which we are able to identify, which we are able to calculate the measure. So this is also line segment. So line segment will have the length, only length will have, or only breadth will have. Okay, line segment will have the one direction or one dimension, that is length or breadth, and the line segment will have the two end points. Line segment will have the two end points, and line segment is a combination of number of points, number of infinite points. So this is about the line segment. Next we are discussing that line. What is line? Same, the line segment I am taking now. This is line segment I am taking. In the line segment, first we need to know the naming of the line segment. How to name the line segment? See, this is AB is given. This is the line segment we need to name now. How we need to name is, what are the points we are identifying on the line segment? Writing those line points on the side by side and writing the line segment symbol on the AB. This is we call as the AB line segment. Then we will, writing of line segment AB is in this way. Our reading is line segment AB. Reading is line segment AB. Line segment AB. Same on the same, one more, the same X, Y. On this now I am taking one more point to say. Now here, if we observe, there will be the 3.3 line segment. See, X, in between X and Z, one line segment we can identify, and in between Z and Y, we can identify one line segment, and in between X and Y also we can identify one segment. 1, 2, 3. Now we can write this as XY line segment and ZY line segment and XY completed, ZY completed. Now XZ line segment also we can take. So these are all the naming of the line segment. Next is line. For line, I am taking one line segment AB. Line segment AB, if I extended in the both direction infinitely, extended in the infinite direction. So AB, this is the AB, these are the end points first. This is the line segment we have taken. Now what we are doing is, this line segment in the both direction if we extended infinitely, then that is called as the line. So this will be write as AB line, writing the points on the line AB and writing two arrow marks in the both directions. That means line symbol on the AB. Now we will call this as the line AB. So for reading this as the line AB and for measuring, reading this as line AB. This is called as the line AB. For writing the line AB, so this is the line AB. Okay. So next, so line will not have any end points. Line is having the infinite length. Line will have the infinite length, and the line doesn't have any end points. So for the line there will be the zero end points, and it is extended in both direction infinitely. So on the line also there will be infinite points will be there. On the line also there will be infinite points will be there. So naming the line also we have completed. Next is the very important one, intersecting lines. Now we saw the line. Now we are discussing that intersecting lines. Intersecting lines. See, now one line I am taking here, another line I have taken, another line. See, line also can be named as by using the small alphabets. Line also can be named as using the small alphabets. Small a, small b, small c, and so on. Small z. Up to small z, we can name the lines. So now, for example, I am taking line L and line M. Here for L and M, if we observe, there is a common point. So here the common point will be there. See, this point is belonging to the line L as well as to the line M. See, for example, I am taking one point here, P. Point P, this is I am taking the point P. If we consider point P is only belonging to the line M. Only point P is only on the line M. If I take the other point here, O, this point is only belonging to the line L. P is only belonging to the M. O is only belonging to the L. Now I am taking this point as A. One point here I am taking this, I am taking as A. So this point is, if we observe, this point is common for the line L and the line M. So if two or more lines have the common point, if two or more lines have the only one common point, then those lines are called as the intersecting line. Then those lines are called as the intersecting lines. If we observe, there will be the common point for the line L and line M. A will be the common point, so these two lines are called as the intersecting lines. Next is parallel lines. So for the intersecting lines, see, for example, I am taking, these are the lines. Whatever the number of lines you are taking, for all those there will be only one common point. So these lines all are called as the intersecting lines. See, line L, M, N, O, P. These five lines if we take, these lines also called as the intersecting lines. Okay. So these are intersecting lines. For the intersecting lines, there will be one common point. That point is called as intersecting point of the lines. So this point is called as the intersecting point of the lines. Intersecting points of the lines. Next is parallel lines. The very important one. Another one is parallel lines. are parallel lines? If you observe in your day-to-day life, for example, you take one ruler or scale. Edges of the scale, if you observe, those never intersect. Edges of the scale or edges of your reading table, so those all never touches those, never intersect. So these are called as the parallel lines. So for the lines, if two or more lines doesn't have at least one point also common, at least one point also doesn't have as common, then those lines are called as the parallel lines. See here, if we observe here, these we taken as the intersecting lines. These lines we have taken as the intersecting lines. See, if we observe these, here we can find out one common point for the line A as well as to the line B. Now what I am taking, line L and line M I am taking. For these 2 points there is no common point. So these points, if we observe, these are never intersect. So these points are called, these lines are called as the parallel lines. See, for example, one line I am taking in this direction, another line I am taking in this direction. See, for these two lines also there is no common point. We can observe here, for these two lines also there is no common point. See, for example, this is line X and this is line Y. For X and Y lines also there is no common point. But if we observe, we have the definition of the line. Line can be extended in the infinite direction. Infinite direction. Now what I am doing is, line Y I am extending in this direction. Now we are able to identify one common point for the X and Y, line X and line Y. So now these two lines are called as the intersecting lines, not the parallel lines. Same, the same way if you observe the line L, whatever the direction, if we extended infinitely, then those two lines never intersect. Those lines are called as the parallel lines, like our railway track. Railway track will have the two tracks, but those tracks never intersect. So the same way, those are the examples for the parallel lines. Okay. Next is ray. What is ray? Now, line segment AB I am taking here. Now what I am doing is, I am keeping the point A as fixed. I am keeping the point A as fixed and extending the B in the infinite direction. Only one direction I am extending. So here the point B and here it is the point A. Now if we extend in only one direction, if we extended two directions, that will be line. If we extend only one direction, that will be the ray. So this is called as the AB. AB, writing the points, whatever the points we observed on that line, writing those, and AB on the ray and writing those, and keeping the line ray symbol on the names what we have identify the points. See, one more point I observed on the same ray. Now we can say this as the AC ray. Now we can say this as the AC ray. Okay. Now AB and AC both rays we can say as equal rays. If we observe, now if it is not there, we can observe the one more ray, that is BC ray. Now if we observe AB ray is equal to AC ray, we can say, but AC ray is not equal to the BC ray. Why means, here for AB or AC there is a common point, a fixed point is A. That means starting point of the ray is A and it is extended towards B or towards C in the infinite direction. So we will say AB and AC are both are the same starting point and same direction. So these two are called as the equal rays, and the BC is the another ray on the given. Okay. Now what I am doing is, the same line segment I am taking A, B. Now what I am doing is, I am extending this in this direction by keeping the B as the fixed points. If I kept the B as fixed point, the same line segment AB both I have taken, and now I am extending the line ray in this direction. Now it is called as the BA ray. We need to name the BA ray. Starting point is always first. Here A is the starting point, so A is the starting point. Here B is the starting point, BA ray. Or else we can say we can write this as AB and towards B side, towards A direction is the line ray symbol. See AB and BA. The BA ray we can read or AB ray also we can read, but arrow mark is must and should in which direction it is moving. See, if we observe, it is taking as example 1 for ray, and now I am taking example 2 as ray. Now, if we observe the 1 and 2, both AB only I have taken, so AB it is in this direction, and if we take BA or else AB. See, both are same points I am taking, and it is moving in this direction and towards B direction, and it is moving towards A direction. Now these two we can consider as the opposite rays. Now these two we can consider as the opposite rays. So examples of rays if we take, we will call in day-to-day life, we can say as sunlight, where it is starting at sun and it is reaching to the earth, infinite length it is moving, so it is the ray we can take as the example, or we can use the torchlight, those also we can identify as the ray. So those are the rays, examples for the rays. Okay, thank you children. Now the next exercise we are discussing, that is exercise 4.1. Here we have the 6 problems in this. So now first question, use the figure to name. So the figure is given, so by using this we need to name these. What are the points? 5 points on that, and what is the line there, 4 rays what there, and 5 line segments what we are able to see, those we need to name. Okay, let's see, first question is 5 points. What are the 5 points we are able to see? Say here we can consider D is 1 point, E is another point, O is another point, B is point, and C is also point. So 5 points we can name as B, O, E, D, and C. These 5 points we are able to see in the board and figure. And a line we need to write. What is the line? See here, from D to B we can take the line. Okay, here we can say DB line. It is also correct name. So DB, how we will name the line? Writing the end points or writing any points on the line and keeping the line symbol on the points. Or else we can write as DE line also we can write, or EO line also we can write, or OB line also we can write, or OD line also we can write. Whatever, in all this whatever we wrote, that all correct only. So the line can be represented with any 2 points which are lying on the line and keeping the line symbol on the name. That is correct. So here we are seeing that any line, any one we can take in this. Next is 4 rays we need to identify. What are the 4 rays? First we need to know how to represent the ray. So 4 rays, see, from starting from O, we can take OC as 1 ray. So direction is very important. Starting point is O and towards C it is moving, OC 1 ray. If we want to take OB also another ray we can say, OE also another ray we can say, okay, or else ED ray also we can say, ED ray, or OE ray also we can consider as OD ray also we can take. These are the 5 rays, 4 rays we are able to see on the in the figure. Next 5 line segments we need to find out. What are the line segments? See, here we can say OC is 1 line segment, and OB is another line segment, OE is another line segment, ED is another line segment, or else EB also we can take as 1 line segment from here to here, or else OE and EO. So OC also can be written as CO, OB also can written as DO, OE also can written as EO, ED also can written as DE, and EB. So these 5 line segments we can consider from this figure. Okay, take the answer. Next we have second question in the third question of exercise. Complete yourself by your own, and if we have any doubts in that, we can go with the doubt clarification session. Next we have how many lines can pass through. Fourth question we have. Second and third question you can complete yourself. It is very easy only. If not, we have the live session to complete the solutions. So there we can have the doubt clarification. Now how many lines can pass through one given point and two given points? See, for example, one point is there. The question is, for example, this is the point. From this point, how many lines can be drawn? See, here not mentioned that from starting of this is not mentioned. From this, how many lines can pass? So, see, for example, I am drawing. This is one line. Okay, one more I am taking. This is. Now one more I am taking. This is also a line. Now we can take this is as another line. Okay, like this we can draw the number of lines, infinite number of lines we can draw from one given point. So there is a chance to draw infinite number of lines. Can see all these lines are intersected at point. So this is the thick part we are able to see, but actually this is not the thick part. If we are taking very small, the intersecting also very small one only. So from this we can draw infinite number of points. So from the given one point we can draw infinite number of points. The next one, two given points. See, for example, one point is given here, another point is given here. So if we want to draw the line, see, passing from these 2 points we can draw one line. From these two commonly we are able to draw only one line. If we want to draw another line, see, if it comes like this or else if it comes like this, but these two lines are not passing from the given this point. So from the given 2 points, if any 2 points are there, from those 2 points we are able to draw only one line. So from the given 1 point we can draw infinite number of points, and from the given 2 points we can draw only one line. We have the question, fifth one. Draw a rough figure and label suitably in each of the following cases. A is point P lies on AB. The question is point P here. Point P must lies on line segment AB. See, I am taking the line segment like this. A and B are the endpoints of line segment. On this somewhere I am pointing P. Now we can say P lies on AB. P lies on AB. So we can say this point P lies on AB. Next one, XY, line XY and line PQ intersect at point M. This is the point. Now for this what I am taking is, this is one line I am taking, this is naming as XY, and another point I am taking this as PQ. See, if we observe the intersecting point here, we can take this name as M. So for this we can say XY and PQ intersect at point M. See, this point is commonly there for the line XY and line PQ. So we can say XY and PQ are intersecting at point M. Next question C is, line L contains E and F but not D. So line L, on the line L we need to find out the E and F but not D. See, first I am taking the line L. See, for example, take this as line L. Line L. So we can represent the lines with the small alphabets beside of the line. So line L contains, I am taking the one point is here E, another point I am taking as F. See, E and F, the 2 points which are there on the line L. Now, point E, line L contains E and F but not D. See, for example, I am taking the point D is here. So, this D is not there on the E and F. Or else this D we can take here also. Or else we can take here also. Wherever. So, on the line D should not be there. Next is OP and OQ. Line OP and line OQ meet at O. Line OP. See, draw the line OP. I am taking this as the point O. This as the point O. And I am taking this as the P. Now, one more line OQ is also there. In this direction, if I take, now the same way here point O is already there. I am writing this as the OQ. Now we can say this OP and OQ meet at point O. So O is at the meeting point of line OP and line OQ. Okay. This is about the question number 5. And we have the question number 6. This is saying the true or false. Read yourself and say, give the answers. Try to give the answers, or else I will explain in the later classes. Okay. Thank you.